Hello everyone. So today we're going to be talking about the assignment 2 lab tasks, how to get started on some of those and what to look out for while you're attempting each one. For that, we're going to need to look over at the rubric. And the lab tasks are defined out here by their topic and then as well as the completion criteria defined in the different categories. One thing I do recommend while you're working through it is try and get it working to the satisfactory category before you try and move on to the superior category, because that's already 60% of that task. So even if you don't get everything working to superior, don't worry about it. There, you can just go and select a different task to try and get that up to the 60% of that. So while we are working through this, as I mentioned before, but do want to reiterate, the superior category, everything has to be working. So this is, yes, the feature is working as intended. Satisfactory is you kind of got it working, but it doesn't cover all the bases. So if there is something from the satisfactory category, even though you do have everything listed in superior, you will get that one instead. Then over in the unacceptable means no, it did not really achieve the goal of that actual task. So even if you do get the arrows working correctly, but you added new axes names while you were creating it, you kind of missed the goal of that entire task. So watch out for anything in the unacceptable category. So as we're working through this, this very first one is directly based off of something we've seen in assignment 1 of how to add the arrow keys to get, or how to add our WASDA to get our movement working. This one wants you to reuse the same kind of concept instead of creating new axes just for getting our arrow keys in there as well. We can add those under existing axes that we've already created for moving forward and moving backward. And this one wants you to get your arrow keys working the same way our WASDA does. Next up, this one's adding a new type of pickup to the game. So last lecture, we actually saw how to create a new pickup and quickly change its functionality. This one's asking for a new pickup that'll actually add health back to our character. As far as how much health and that it's adding, that's completely up to you, but it is make sure that it's never going above the maximum health. So for example, if you already have maximum health and you hit your health pickup, it should never increase your health once you've already have that maximum health. So this one's talking about changing our current health, not the maximum whatsoever. Now, whether the pickup, when you run into it, just automatically refills all your health to full, that's completely up to you, or if it just does one health at a time, also up to you. But we've already taken a look at how we can add a damage pickup to the game. And when you think about it, health is really just taking damage away. So that's actually a pretty big hint that you can reuse that same concept of apply damage, but maybe apply some negative damage to actually get our health working. That would also automatically go through our take damage function, which does a clamp to prevent it from ever going above that max health. So there's a lot of different ways to implement this, whether you're reusing that same apply damage method or rolling your own, kind of similar to the max ammo pickup. Just watch out and make sure that you are only adjusting the current health and not doing the exact same thing that our max ammo pickup was, which was increasing how much health we had total. This next one is one of the first research assignments that isn't based off of something that we've seen before. So this one talks about looking at the third-person template from the Unreal Launcher in either the research or the ILA task. It should have had you install one of the templates. So should have had you create a project with one of the templates rather. And I should have one in here. Should have organized this a little bit. Third person, why not? Let's try and open that one up. So while that's loading, let's take a look at the criteria here. So this is actually going to replace your idle to run transition. There should only be one in the graph now, and it'll be using what is called a blend space. As far as what a blend space is, like I mentioned, we didn't actually cover that in any of the material we've worked with so far. But in here, this third person BP, I want to bring your attention to this third person overview. This third person overview, if you actually click on the play button, will bring up a built-in tutorial. And right on this very first one, there's a link to a YouTube playlist. The YouTube playlist goes over kind of how they set up several different things working in this project. Starting at number 7, it starts talking about blend spaces. So they actually do a very great job of explaining what a blend space is, how to use it, and then in the future ones, they actually show how to add it to the animation graph and stuff like that. So please use that as a quick reference. It is done in a rather old version of Unity, so some things may have shifted around. One thing I'm going to point out for that is, well, let's actually just bring this up. When they get into their blend space, they actually have their idle, walk, and run and like axis labels and stuff all right here down in this bottom section. They've moved that around in newer updates. So taking a look at this, it not only has that blend space in it, we have a direct reference of it being open in a newer engine. So if we look for their blend space, they have their third person idle run 2D. And of course, they want me to install updates right as I'm doing a lecture. So we're going to ignore that. And here's what their blend space looks like. We see it doesn't have, okay, no worries. So down here, they don't have that axis settings or anything anymore listed here. That's up in the asset details, and they put it all right here for the axis settings where you can change the name, what the values go to between 0 and 375 is what they're using. And this actually allows, if we're holding shift, to drag our preview so that as we start out from our idle and slowly get our speed up to about 100, we see we're doing a walk. And as we continue on and go even faster up to 375, we're going to be blending to that full sprint animation. So that's a quick description of that. But one other thing that I do want to point out is what values you want to set this to. So they have theirs from 0 to 375, and those are actually defined in the character. Our character movement, we never told it how fast to actually go, and that's going to be in third person BP, where they create their character. We just inherited and left everything default for our character movement. This character movement component comes with a lot of different settings. Down here in walking, the max walk speed is actually how fast your character gets going when it's walking on the floor. There's a few different other options and stuff you can change because when we first start playing it, it'll probably try and sprint and go full speed immediately as soon as you press W, because we're just using the keyboard. We can't really vary how much that button is pressed. So if you do take a look, one more thing, at the labs done build, the example used for demonstrating this in-game, while it's not needed, take a look at those notes provided with it. For the different thing for the blend space, it actually talks about what settings we change to allow a ramp up in speed, even if we are just using a keyboard. So this comes in quite handy, just to compare to your build when you're trying to demonstrate these in games. Keep in mind, it's not needed to actually change that setting for the task. We will actually be looking at your setup from the project you've provided to make sure that you do have it implemented in the animation state machine, even if the keyboard from in-game doesn't appear to be showing that blending. So that's a couple of things I wanted to talk about for the blend space. Next up, we've taken a look at our bin walkthrough in the documents of how to get the actual stop of our character and stop movement when our character's reloading. So it disables the movement when we first press reload, and then enables it again or sets it back to walking after the reload animation's finished. If we take a look at how we have that currently set up, we see our base character is handling our different input actions as well as the reload weapon. Now this reload weapon event actually gets called from our animation system. That's when our animation, or when our reload animation is actually fully finished. Our shooting, we do have our input action right here and then a shoot weapon. One big difference between our reload and our shooting is that our shoot weapon happens before the animation is actually finished. So if we actually go and find out where this is called from, we'll find in all references, we see our animation blueprint is the one calling shoot weapon. So we can pull that up, don't need to search for anything now. We have all our anim notifies and stuff right here. So our reload finish is where we're actually telling it to reload the weapon. Our attack finished, we aren't doing anything with. Our ready to fire is when our shoot weapon happens, and our ready to fire happens before our actual attack animation is finished. So we can't just directly copy how we did it for the reload weapon. We'd need to change some things. For one, we could have it so that our animation system is the one telling it when to actually disable its movement and enable its movement again. We could set that up right here. For example, I'm going to replace our reload weapon rather than having our character do our disable movement and our setting it back to walking. If we just test that out, make sure that if we run and reload, we see we do have the sliding now. So if I wanted our animation blueprint to do this, well, when we first tell it to play the animation, we can get our owner. And we could go ahead and tell it, or ask our owner for get component. And we'll look for by class, so we can specify what type of component we want. So this should look kind of similar to a get component from Unity that you're more familiar with. And we can say any type of component we want. Well, we have a character movement component that actually has our movement. Get that character movement, and we can tell it to disable that movement. So when we tell it to play that reload, it's going to disable that movement. Let's just test this portion out. If we press reload now, we see our character stops. And we never re-enabled our movement, so I'm pressing WASD right now and it's not doing anything. But in our animation character, we can just go to where this animation's finished, and that's in a notify, where we're actually turning that is attackable off, and we can do the enable movement or set it back to walking. So we'll get our owner, get that movement component. And the component we're looking for is a character movement component. We can go ahead and set movement mode right after we turn that bool off, because our, oh, that's attack finished. I meant to do that on reload finished. Control X to copy, or to cut. And we'll just paste that right in here off the reload finished. So it is easy to make mistakes like that and connect it up to the wrong thing. Just make sure you reread everything, go from the beginning. All right, reload finished, turn that reload bool off, tell our character to actually reload the weapon, and let's set the movement mode back to walking. So now we should have the same behavior as before, but all of our code has been moved over to our animation of when it's going to stop versus start moving. Makes it a lot easier if we're trying to connect something up to attack finished, rather than creating a new custom function or custom event on our character to tell it to start walking again. Just a little bit cleaner. Alrighty, so that wraps up that one. Big thing, if you do just kind of copy it exactly how we have the reload working and just going off of the shoot weapon, that would just be satisfactory because it's not waiting till the animation actually has ended. And it does leave an actual window of opportunity to click again, and it won't actually shoot again, but it will stop the movement and lock your character up. So swapping it over to the animations and everything would be a little bit cleaner for the superior category. Next up, so taking a look at our projectile, we've seen how to actually spawn an item, as well as like actually spawn it in a specific spot using a socket location. This one asks you to set it up so that when our character dies, they're going to drop a pickup. It also asks you to add something in that we haven't talked about too much yet, and that's actually that the pickup that it's going to drop will be randomized each time it actually goes to drop one. So we'll talk a little bit about that, but the big one for this is you're going to have to take a few things into account. If you just get a pickup spawning in the world, it's not random, then it would just be satisfactory. If you don't give it enough time to actually play the entire death animation, it would still also be satisfactory. So that's one of the reasons why I mentioned getting it up to that satisfactory, and then maybe switch over to another task before revisiting if you are struggling with the extra only 40%, which in this case would be 4 total points for the assignment, versus attempting another one to a satisfactory category. So making sure that a pickup is spawned, if only one can spawn, satisfactory. If no pickup drops or a pickup spawns at another location than the actual character's position. So if you just say spawn actor of class, and that's all you're doing and never passing in the current character's location, it would be unacceptable. So if it spawns a pickup, for example, if I kill that character over there, and it would spawn a pickup like over here at origin, not actually where that character died, then that would be unacceptable. It should appear as if that character is the one that dropped that pickup. So a couple of things about that, just reference how we're actually spawning our projectiles, how we're actually getting it into a specific location. And then the other part is for showing the entire death animation. Well, one thing about that, sorry, jumped over to the wrong project, is we do have a spot where our character dies. We've actually set up an event for that. We've called it character death. So character death is from our killable. Our killable lets us know when our character actually died. That's how we're telling it to play its death animation. If I were to actually look past this part and see this part right here, we see this is doing a cast to a player controller. So this is specifically asking, is the thing that's controlling this a player or not? If we try and connect stuff up off of this, that's using an actual branch. So that's only going to happen if it's a player character. If it's not a player character, that would be our cast failed right here. So we want them to spawn for both different interactions. So if we did add a spawn or something here, I'm going to just add a print string. If we only have that connected up to the top branch, and we test this out, should be printing hello when a character dies. But because we only have that on our top branch, we don't get that print happening right now. If we also say when our cast fails, rather than trying to disable input because we don't have a player controller, we'll just go straight over to the print string. We should see that it happens when our character dies, so we got that hello print, as well as when the player controlled character dies, we get another hello. And in case you missed those, we can always open up the output log, hello for character underscore 2 and hello for underscore 0. All right. Now, if we wanted that to happen, not necessarily as soon as the animation started playing, there's a very useful node that says, well, we'll just say this is started death animation. There's a very useful node when you're inside an event graph, and it's something called delay. Delay allows it to get to this point and then pause for a certain duration. Let's say we're going to pause for 5 seconds. Then after that 5 seconds is up is when this next completed exec will start running things. So let's add another print string. Delay is up. Let's take a look at how things are working based on the sequence they're connected to right here. So if we kill this character, we see started death animation, and delay is up 5 seconds after. So that's a couple of things to take into account. So you could, rather than just do a print string, spawn something there after the death animation is up, depending on how much you set for your duration. Then you could do something else over on that other side. Big thing to take then into account is how these execs all go into each other, because this is a branch right here. Casts do branch, whether it succeeds or whether it fails. So we do want both our player and our other character to be able to spawn things. The other thing that I wanted to talk about is the random. So we haven't talked about random yet, but let's just get rid of that delay now. I don't want to show you too much of it all working together. If we were to take a look at the kind of random options that we have, we can right click and just look at random. There's a whole bunch of different random stuff, whether it's random integer, random float, random bool. Well, random bool was the easiest form. It can only return true or false. We could then combine that with a branch. And we could say This one is option 1, took branch 1, and we'll copy that. And this will be option 2 if we add another option. So now, if we had a few of these enemies in here, and if you don't know, you can hold Alt. So if you tap Alt and then hold and drag a character to a new location, it'll duplicate it automatically. Control W is also the duplicate keyword in here, or shortcut in Unreal. So we've got 6 characters there. Just to make this a little bit easier for demonstration, I'm going to make it so that my base projectile does a bigger amount of damage. Let's say 5, so it'll kill them in 1 hit, just for quick testing purposes. If we play this and we kill them, we see that one took branch 2, that one took branch 1, branch 1, branch 2, and we actually have a randomized branch to tell it to do one thing or do another thing. That's just a quick setup showing you how you can actually have different code run based on a random value. Obviously, you'd replace the print string with what type of object you're spawning or something like that. Alrighty. So that pretty much wraps up and should give you a good starting point for how to actually spawn something based on a random value. This next portion is talking about blending our health bar from its start color, which is green, to red, based on how much health it has. So if we take a look at what kind of things we've done with our HUD so far, our HUD does have a progress bar representing how much health it has. On that bar, we're actually filling out this percent variable, which is a value 0 to 1. If it's halfway, then it's 0.5. That's important that we already have a value 0 to 1 for our health. And we're getting that from our player based off this binding. We're actually asking our character, what is its current health ratio? Well, back in the designer, we can also change what color it is down here. We had it manually selected to green, but there is an option to bind this and have code run to get its value. We can create a binding, and this one's actually requesting a linear color structure instead of a float. Well, if I look at what kind of option lerp gives me for this, since we're dragging off an input pin, it's asking for actions that'll actually give us a linear coloring structure. So there is lerp and lerp using HSV. We'll just use the simple one, lerp. Lerp actually takes a value, or takes 3 different values. A, which is its starting color, and B, which is its ending color, and alpha. How much should we be at A versus how much should we be at B? Alpha is a value between 0 and 1. When it's at, and actually let me just go ahead and set this. So if B's red and that one's green, right now our alpha value, we haven't passed in any value, we're just hard-coded it to 0 right now. It'll be 100% A. So if we test this, we should see it green, even regardless of how much it's showing. We would want to do the same thing for our alpha value of our get health ratio. So we'd want to use the value from our actual character for how much it should be of this color versus that color. If we do have this set to 1, that'll be our full B value. So even if we're in our designer, it'll look green because that's what our preview color is set to. But if we play this in game, we see now it's actually running that binding, and our binding itself is just telling it we have an alpha value of 1 right now. So you do have to make sure to get that value from our character and pass it in there. That's about it for that one. The satisfactory is if you found a tutorial online and it's checking like, oh, well, we'll show green if it's above half health and stuff. It should smoothly transition as it actually goes down, not just at a specific health threshold, it switches over. On that note, if you left everything default for like these pickups and stuff, our pickup damage, if we open that blueprint up, by default, it was doing 5 damage each. I would recommend changing this and dropping it down so you can see that health bar go down in value and stuff. And even if you drop it to like 1 or 0.5, it's totally up to you what those values are. Just make sure that there is actually enough in the level for testing purposes to kill our character. So now we should actually see it drop down 1 each. Alrighty, moving on to our next one. So this one's talking about adding shields to our base character. The shields should work pretty much the same way health does. Our health, basically just go through those different steps of adding health. We want this showing on the HUD and it having 2 different values of current shield versus max shield. So go through those same steps, just replicating everything with a different name talking about shield values versus the health values. Now the one challenge of here is actually incorporating it to work so that if you have shields, that's the first thing that should take damage. If you don't have shields, then you can actually damage your health. So looking at our killable currently, another thing about that, do not create a new separate killable with shields and stuff. Just go ahead and add the extra variables right into the killable. It'll be easier to actually work with and figure out, do you have shields or not, right off this. So for example, our take damage, the first thing it's ever doing is setting the current health. Because that's the first exec in the line, it actually gets to this and then evaluates all these nodes while it's running this. If we wanted to do something before that, we'd need something for this exec to go to first. I would recommend a branch, and the condition for our branch should be, is current shields greater than 0 or not? And then if it's greater than 0, we'd do the same thing that we were doing for health, but for our shield variables instead. Once our shields hit 0, that would be, then it would start running our false branch, and we would actually just do our health like normal. On this, if we actually look at towards the end of it, we are doing a quick check with our current health. We're asking, hey, is our current health greater than 0 towards the end, just as a death check? That same concept can be done right here on the branch before we try and damage anything, checking, do we have any shields or not, before we try and tell it to set our shields or set our health. That's about all I can show for that one without kind of just doing all of the steps. So for that one, pretty much follow the same concept as our health stuff, and then the one tricky part to that will be adding our branch in the proper area so that it only damages shield or only damages our health. I have had a few students ask if there should be any carryover of shield versus health. Like if you have 1 shield left and you take 5 damage, the only thing that should do is knock out the current health, or knock out the current shield. So our take damage should only ever damage our shield or our health one at a time for each amount of damage it's taken. Should never really damage or have any carryover unless you do the extra math to take out what you've already done. So that's just a couple of things about that one. And then this last one is asking you to add a gun model to the base character. So we haven't really talked about attaching models to other models or animating them and stuff like that. There's a couple of things I'll show you real quick about that. The biggest part to this will actually be swapping out all of the animations and getting all of the transitions working. Keep in mind that the new animations are a bit different and will require different transitions in order for them to work. So before we talk about the transitions and stuff, let's talk about how we can get something attached and animating with our character. So let me close out of all the extra stuff we have. I will work with the animation blueprint and our character blueprint to demonstrate this. In our viewport, if we take a look at our current components, we only have one mesh right now. If I want to attach another mesh, we can go ahead and look for mesh. There's several different options for meshes. So what you're going to be attaching, you're going to want to pay attention whether it's a skeletal mesh or a static mesh. For purposes of this one, I'm going to just show attaching a pickup to, let's go with the head. So this will be our pickup mesh. And we've just dropped this static mesh on here. In order to make sure we attach it to the animation, it has to be a child of the animated mesh. So we're going to drop that as a child. We're going to want to choose what mesh we want to use. Let's just do chest 3. We see that's not animating with our character. It's also ridiculously huge. We'll scale that down and want that locked. I wanted to lock it when it was normal. We'll scale that down like that. We'll keep the location as 0. Right down beneath our transform, there's something called parent socket. Parent socket doesn't let me actually type anything in here or anything like that, but it does let me select this magnifying glass. It immediately shows me any joints that we have, or even any sockets that we may have created. We created that shoot location socket. So if we want to attach this to a very specific location, we could go over to our animation blueprint. And over in the actual an animation that we'd want to preview, let's just open one up. Let's just do idle for our purposes. We're going to pause this at a specific spot so it's not moving all the joints around. So I said I wanted to attach this to the head. We'll go to our head and we can add a socket right here. Just so we can move it outside of the head so it's like a hat. We have our head socket. I'll rename this pick up attach. And we can move this around in the viewport right here. Oh, I didn't want to drag the actual head out. Oh, I forgot I renamed it and had this, whoops. That looked painful for a moment. Let's actually move this socket out. And we see that this socket's up here now. So now that we actually moved the socket and not the head itself, we'll go ahead and see, like, if we wanted to preview something in this animation, we can right-click that socket and actually add a preview asset right here. We can choose, well, quite a few different preview sockets to attach to a socket. And let's go with that chest that I wanted to show. We see obviously that's not going to work as a hat. So we could rotate around, move that up, make sure that it's just in the right spot. And keep in mind, we are just moving this socket position around. We could even set the scale. Ooh, that's tiny. 0.3 each. Move that back down so our character will be wearing a hat as a head, or wearing a chest as a hat, rather. We definitely want to save this. Now we've done with the animation. We've got a socket created, save that. We notice our skeleton does need to be saved. It's got a little asterisk next to it. Let's just go ahead and click Save All. Make sure to save everything. Okay, if we look at our character, our mesh isn't attached to that socket yet. So that's where that parent socket comes in. We can tell it to go straight to that pickup socket. Now, because I moved this around and different things like that, we're going to want to just reset everything from this transform, since we are using the sockets transform directly. And with that, we'll notice all our characters, including our main character, now are wearing a hat on their heads. So that's just a quick way of how you can actually attach that. The other part is the animations, and like I said, this is going to be the much bigger part. So our animations, if we actually go to, I'm going to close out everything so we don't have so much open. If we go to our state machine, and we want to swap out one of the animations it's currently playing. Let's say we're going to swap run, well, let's do reload. If we want to swap out reload, rather than dragging the new animation on here from the gun animations, which I never talked about. Oh, crap. So before I get into that too far, under the PGF2 assets, we have provided a gun mesh for you. Keep in mind it is a skeletal mesh, as well as under animations, we have all the normal animations and all of our gun sets of animations. So keep in mind, nothing this class ever asks you for will require you to find some random animations or anything like that. The most we will ask you for is like, hey, you're going to need a different visual component, such as a sphere or a cube, just some of the basic built-in stuff. So we have provided all these new animations for you. Over here, as I mentioned, if we wanted to change this reload state, if we drag the reload rifle hip, which is what the gun animation is called on here, I don't want to go through the hassle of recreating all of the transitions and everything for that. What I can do instead is just go into this reload state by double clicking it. And rather than having it say play reload, if we drag an animation in here, it'll play that other reload animation. Give that a compile, and we do reload. Our old one was the crouch animation we saw before. This isn't a direct fix because we see our motion state machine. It's currently stuck in reload. So you are going to have to fix up the transitions. Let's see what our transition back from reload is. You see that's checking get instance asset player time from end. Well, if we open that up, we see it's looking for the time remaining of reload. Well, we're no longer playing reload, the animation. We're actually playing reload rifle hip. So we would need to replace that with time remaining, but rather than the reload, we want the time remaining of the actual animation that we're playing. So all the animation transitions that we had set up before, we'll need taking a look at. So now we press reload, should transition, and we see it finishes because it's now our transition back is now checking the correct animation. So I'm only going to show you that reload one. You do have to replace the very specific ones for attacking, idle, run. If you got the blend space in there, you're going to want to update those animations for, I believe it's called jog in the gun animations versus a run, sprint or something. So you will have to replace all of those animations. And the biggest part you're going to struggle with is how our attack animation works. So our attack animation right now is just using an automatic rule. Taking a look at how that works, I'll give you a couple of hints right here. If we hover over that, we see it's talking about it'll automatically switch once the remaining time of the animation and the crossfade duration is a certain amount. Our new animation for the gun shoot is very short. In fact, it's so short, it's the same amount of duration that we have right here. This duration actually says when we're 0.2 before the end, we're going to kick out and return to idle. Well, if our entire animation is only 0.2 long, it's going to immediately go try and play, but say, oh, I've already reached the end because I'm 0.2 away from the end, and try and kick it back to idle. So you may want to modify some things over here, maybe even not use an automatic rule and say, I want it to play the entire animation rather than ending 0.2 early, things like that. One other thing I do want to mention is that while you're in each one of the states, you have the ability to change how fast it's playing right inside here on the play node of the state, as well as whether you want it to be looping or not. A couple of things while you're trying to figure out how to get the new animation working on that. One last thing that I want to talk about is our AC attack itself is how we actually told it when to shoot. It's very important that you still set that up, even if we're not playing AC attack, when we're playing a different animation, it still tells the character when it's actually ready to shoot. So just keep that in mind when you are working through the different transitions and swapping out all the animations. Other than that, that's about all I have for you today. One other thing with this is it wants you to adjust the actual socket location rather than from the tip of the hand, is from the tip of the gun. So keep that in mind when you are setting up the sockets. That's one of the reasons why that preview comes in so handy, so you can place it right at the end of the gun. That's about it for today. Were there any questions that you guys had for any of the stuff, or? Alrighty. Well, I'm going to go ahead and end the session, and I hope you have a good one, and see you guys all on Wednesday.